Hey guys, today we're going to continue with circles and the equations of them. We're going to talk about how to graph and how to make equations when given various pieces of information here. So first we'll start off with a couple of graphing. The first one we're going to look at is we have x squared plus the quantity y plus 2 squared minus 4 is equal to 0. And we want to graph this. So we're going to try to graph this circle. In order to graph, we need to convert into this form, our standard form of a circle, y minus k squared equals r squared. So we have to convert to this. If we look, we're actually rather close. All we have to do is get that 4 over to the other side. So you can go ahead and add 4 to both sides, and we'll end up like this. Now we're in the right form. Once we're in this form, we can pull out the information, the center of the circle. Well, that's going to be x minus h, that's like a 0 over here, if it's just x, so it's 0, and your y minus k, it's like minus -2, so we're going to have -2, that's your center of the circle, and our radius, it's going to be the square root of whatever we have here, so it's going to be the square root of 4, which we should get as 2. So if we want to graph this, we just hop on over to our center, 0, -2, and then we're going to use a radius of 2. I just like to go 2 both horizontally and vertically in both directions, and then you draw your circle in. So the key thing with a circle is you're supposed to be 2 units away at all times, so do your best to stay 2 units away. It's not the easiest. There's my best circle. So this would be the circle represented by our equation right up here. That was our first. Our second, let's go ahead and erase. We'll keep the standard form though. Our second one, and we saw something a little like this yesterday, so we'll do a little more with it. We have x squared plus y squared plus 8x plus 40 is equal to -14y. Oh no, positive 14y. And we want to first convert this and then graph. So to convert, what I'm going to do is I'm going to say x squared. I'm going to bring the 8x and put it right next to it. Plus y squared, I'm going to subtract 14y from both sides. And I'll subtract 40 from both sides. So we're going to end up here. Everything is like in its position that it needs to be. We just have to do a little bit of work. So we need to turn this into this. So we need to turn this into a perfect square. And we can turn it into a perfect square trinomial by simply completing the square. So we're going to end up with, we're going to take, let's do it like this, x squared plus 8x, and we're going to add, remember this is like your b term, so half of b, which is 4 squared, is 16. We're going to add that. Then over here to complete the square, you're going to take half of what your b term is, so -7 squared is plus 49. And then over on the right side, the property of equality says we have to add to both sides to keep the equal sign true. So we're just going to look like this. Now the whole purpose of this is now we can rewrite this trinomial here as x plus 4 squared. We can write it as a binomial squared. Then this trinomial we can write as y minus 7 squared. That's the purpose of completing the square. And then when we combine like terms over here, we're going to see that everything works out really nice for us. We end up with 25. That's a good number to have. Now we can go ahead and figure out what our center is, because now we're in the right form. So our center should be, well, -4, +7, and then our radius is going to be the square root of 25, which is 5. So let's go ahead and graph now. We're going to be in this quadrant here, so we're going to be at -1, 2, 3, 4, 2, 4, 6, 7. This will be our center. And now we're just going to use our radius of 5, and again, since it's a nice number, I'm going to stick to going vertically and horizontally, 2, 4, 5, 2, 4, 5, and you want to stay the same distance away at all times, so it shouldn't look like a rhombus, it should look like a circle. So there's my circle for this one. And we're all done. Alright, so now we're going to talk about a problem. We'll do a couple of problems actually. The first one we're going to be given, we'll keep that. we're going to be given just 3 points that fall on the circle, so like 3 points that fall on the circle, and then we're going to have to figure out the equation for the circle. So let's figure out what we're given here. We're going to do this one. We're given the points R is 1, 2, that's going to fall on our circle. We're given the point S is negative 3, 4, that's going to fall on our circle. And we're given the point T is negative 5, 0. That's going to fall on the circle as well. So all 3 of these points are points that lie on the circle, and we want to write an equation in standard form that will tell us, or that will be or represent the equation of the circle. So lie on circle. So if we look kind of at the graph of these points, we look at 1, 2, that's R. We look at negative 3, 2, 4, that's S. And we look at negative 2, 4, 5, that's T. There's going to be some circle that goes through these 3 points, and we want to get the equation of that circle. So we have points on the circle, but we need the center of the circle, and we need the radius to figure out what the equation is going to look like. So instead of thinking of these as the 3 points that fall on the circle, how we can do this, and we have to think back to when we covered these, we're going to think about this as a triangle. And there is a special property in triangles. If you find the point of intersection, the point of concurrency actually, with the 3 perpendicular bisectors, then you're going to find what we call the circumcenter of the triangle. What's special about the circumcenter is that's the center of the circle that goes through each one of the vertices in a triangle. So we need to find the perpendicular bisectors, find where they intersect, and that'll tell us the center of the circle that goes through each one of these points. Now the nice thing is you only need 2 of the perpendicular bisectors. If you do all your work correctly, they're going to intersect at the same point that the third one will intersect as well. So we're going to do it with 2 of these and just make sure that we're doing everything correctly. So we'll be extra careful. So let's focus on, let's do RS. We'll look at RS. So RS, in order to find the perpendicular bisector, we're going to need to find the midpoint of RS. So the midpoint of RS, we'll call it point P. So in order to find the midpoint of RS, well, you're going to take the x-coordinates, you're going to add them and take half. So you add the 2 x-coordinates, you get negative 2, take half, you get negative 1. And your y-coordinates, you add and take half. So P, negative 1, 3, that's the midpoint, negative 1, 3. That is the midpoint of RS. And if we're going to be interested in the perpendicular bisector, we need to find a line that's perpendicular to RS. So our slope that is perpendicular, well, that's going to be, let's see, RS has a slope of change in x is 2, change in y is minus 4. So our slope of RS is negative 1/2. Could also use rise over run here. So our perpendicular slope is 2. And we'll take this work away. And then we can, in a second, we'll find the equation for that perpendicular bisector. Let's go in red for our second one. And we'll work with, let's do ST. So ST, we have to find the midpoint. So the midpoint of ST, we'll call it point N. So go ahead and take your x-coordinates, add them, take half, you'll get negative 4. Take your x or y-coordinates, add them, take half, you'll get 2. That's going to be your midpoint for ST. And to find the slope that's perpendicular to ST, well, we have a change in y of 4, change in x of 2. So the perpendicular slope is going to be the opposite reciprocal, negative 1/2 would be your slope. And we'll take that away. All right, so now let's make an equation. Oop, that was point N, we called it. So let's make an equation for each. In order to make an equation for RS, well, we know the slope is 2, so we're going to be 2x plus b. We can substitute in, so y is 3, when x is negative 1, so our b is equal to 5. So our equation would be y equals 2x plus 5. That's going to be your equation to represent the perpendicular bisector for RS. It's going to be, yeah, right here. This will be our line. Then the perpendicular bisector for ST, where we know it's going to be y equals negative 1/2 x plus b, we can substitute in, y is 2, and x, when you substitute in, this whole thing simplifies to 2 plus b, so b is 0. So our equation is y equals negative 1/2 x. And if we go over, we'll get rid of u. If we go over here, negative 1/2 x, that would look like this. And just like that, we might be able to tell just from looking at our graph, that's where we're going to intersect. But if you didn't know, we could just do a system of equations. Let's get rid of all that. We can say this is, you could say 2y equals negative x, actually negative 2y equals x, and then you can use the other equation to find that. That was terrible, Grace. It's better. So to find that point of intersection, we're going to do a system, and you could substitute in. You would have y equals 2 times negative 2y is negative 4y plus 5. So 5y equals 5, y would equal 1. So our point of intersection would be something comma 1. Substitute in up here, you're going to get x is negative 2. So this, we'll call it C for center. This is going to be, well, negative 2, 1. You can see on the graph, that's where they intersect. That's going to be the center of the circle that intersects all 3 of those points. I'm going to clean this up now, if we want to graph now as well. Our center is negative 2, 1. We have R is 1, 2. S was negative 3, 2, 4. And T was negative 2, 4, 5. And if you actually look into this, you can tell they're all the same distance away. They're all going to be, if we make like a right triangle for each one, they're all going to be a right triangle with one side of 3 and the other side of 1. So one leg is 3, the other leg is 1. One leg is 3, the other leg is 1. So we know we are the same distance away from all of them. And if we use those little right triangles, or you could use distance formula, essentially the same thing. But if you make one of those triangles like C to T here, it would look like this. This would be the radius, so it would be square root of 10 would be your radius. And if we want to make an equation for this, well, we have all the information we need. Our equation, and perpendicular bisectors are going away. Our equation, we have x minus negative 2, so x plus 2 is squared, plus y minus 1 squared, there's your center, equals the radius squared, so the radical 10 squared is 10. So this would be the equation for the circle that goes through all those points. A lot of work for that one, it's very involved. Need a lot of different things that we use this year in Algebra 1, but it is possible. Alright, our last problem we're going to do is we're going to look for intersections here. So let's say, this one's a little bit quicker. For this problem, we want to see where the circle represented by this equation, we'll do a nice one, nice and easy. The equation x squared plus y squared equals 8. We want to see where that intersects with, let's do this one, the line y equals negative x. So whenever you're looking for an intersection, even though this might not look like something we've really worked with in the past, we still can make a system out of it. And all we're going to do is now we're going to substitute in. So we take this first equation, x squared plus y squared, and that's going to become x squared plus negative x squared equals 8. So we should, when we square this, end up with x squared plus x squared. So we're going to have 2x squareds. And then you're going to find out that x squared equals 4. So therefore, x equals plus or minus 2. So that means this line is going to intersect with the circle when x is positive 2, when x is negative 2. So when x is positive 2, well, your y value, if x is positive 2, your y value is negative 2. So this is one point of intersection. And the other point of intersection would be the case when x is negative 2. And if you put a negative 2 in, then y would be positive 2. So these will be our 2 points of intersection here. And just like that, you found where the circle intersects with this line y equals negative x. You can treat it like you would in a system. You can look for different points of intersections and such. Alright, that's all we have for today. Go ahead and practice some on your own. Have a nice day, guys.